Hey, what happened? So the same number as we discussed the idea of mean, the same numbers, same data set. So what is the number that takes the most midmost rank? 62, right? Right? It's here. Hey, left to 62, they are four numbers, and the right to 62, they are also four numbers. So 62 is the midmost numbers. Okay. So what happened if we drive this number all the way to the right? Hey, 215. 215. Hey, it is still takes the midmost rank, right? Again, it is also it still takes the midmost rank, even if it 150 115 is pulled to the right into 250. What happened if it is 350? What if it is 350? 315. Hey, 62 again takes the midmost position, right? Is 62 all the time. Whatever the value of the whatever no matter how the extreme value was pulled to the right. Understand? So it is robust against the extreme value, not influenced, very stable. Okay? So what is the difference between mean and median? To obtain median, we have to rank the data first and take the value that stands at the most position, right? And number two, median is robust against the extreme value or values. Understand? Understand? Yeah. So what if, hey, in this case, there are 9 numbers. So we have the most position that the value that takes the midmost position is the fifth one when the total number of data set is 9. So we take the fifth rank. Okay? What if there are even number of data? What if there are even number of data? What if? Yeah, even number. Not 9. But for example, it's 10 this time. Either it's 5 or 6 is not okay. What if the number of data set, the number of observation is 10? The fifth one or the sixth one? What? Yeah, the average of the fifth one and the sixth one. Understand? So what did I comment here? What did I comment here? Hey, the median is robust against extreme values. The mean is markedly influenced by the extreme values, while the median is robust against the extreme values. That's the difference. Understand? Hey, it's going to appear. It's going to appear in the midterm exam. All right? Hey, it's influenced. Yeah, it is also pulled to the right by the extreme values. Okay? But here, it is not influenced. It always takes the midmost position. It always takes the midmost rank. Understand? Okay. Okay. Let me insert a slide. Let me insert a slide here. So what if the number of observations is even, like n equal 10? Either the fifth or the sixth is not okay. In this case, we take the average, we define the median as the average. We define the median as the average of the two. I.e., that is to say, median equal the average of the fifth one and the sixth one. Okay? And to generalize, hey, bracket. The bracket here means the fifth observation. The bracket here means the sixth observation if you have already sorted the data from low to high. All right? So to generalize, the median of x1, x2, all the way up to xn is defined as median equal x bracket 2n plus 1 if n is odd. Okay? And the average of divided by 2 if n is even. All right? You see that? I will explain. I will explain the symbol, a bracket symbol later. Next slide. I will explain this. Hey, the bracket, not parenthesis. Oh no. Sorry. Sorry. A parenthesis. You should be parenthesis. Sorry. It should be parenthesis, not bracket. Not bracket here. Parenthesis. The fifth one the sixth one. Yep. For example, here, hey. Okay, here, are the sorted values of x1, x2, x3, all the way up to xn. Okay? For example, like this one. This one. Yeah. I'm a very lazy person. For example, this is x1. This is x1. This is x2. This is x3, x4, x5. Whoa, 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 whoa. Parentheses, don't forget. X6, x7, x8, x9. Okay? It's sorted. Our sorted observation of sorted value of this one, the original data here. Okay? Yeah, sorted. And this number are unsorted. Okay? Yeah, this number, not sorted. And this is the raw data. Okay, where is it? Okay? Yeah, here. The unsorted raw data. Paste. And this is x1. This is x1, x2, x3, x4, x5, x6, x7, x8, x9. Okay? Understand? Understand? These are raw data set. Okay? And these are the sorted result. And we use the bracket. We use the parenthesis x sub parenthesis 1 to mean the first one. And it means the one that takes the second rank, the one that takes the third rank, and the one that takes the ninth rank. Okay? And in this case, when n is 9, which is odd, then median equal x 9 plus 1 divided by 2. So it is the fifth one. One at the fifth rank. And when n is 10, which is even, then median equal the average of the fifth one plus the sixth one. Sorry. Okay, that's the median. Understand? Okay. It's going to appear in your midterm exam. The comparison of median and mean. So besides median and mean, there is also another, or you can say there are also other alternative. But I'm going to introduce to just one more, which is called the mode. The mode, okay? The mode here. MODE. What happened? I have to wipe them off. Otherwise, yep, here. The third one is the mode. Hi. By the definition given in your textbook, what is mode? The mode is defined as the value that occurs most often in a data set. Okay, the value that occurs most often in a data set is called the mode. Okay, I have to wipe them off again. I have to wipe this off. Okay, let us take a look at an example. Example 3 to 6. Hi, public library. Number of public library in a sample of 8 states. I mean, the states must be must mean the states of the United States of America. Hey, 8 states. The first state, in the first states, there are 114 public libraries. The second state has 77 public libraries. And the third state, I think it's Alaska, only 21, or Hawaii. It must be a very small state. Okay. Okay, so what is the mode in this example? Hey, the mode is the value that occurs most often. Hey, it occurs once. 114 occurs once. This one occurs once. Only 77 occurs how many times? 77 occurs how many times? Twice. Understand? So which one is the mode? 77. Okay. I have to wipe this off because I don't want to have my salary get cut. Okay. So mode is 77. Okay. And it's a local time. Ready? Your cell phone. Hey, you got only 10 seconds. Because I don't want you to pass it to the absent students. You only have 10 seconds. 10秒钟, okay? Because I don't want you to pass it to the absent students. But now it's okay. You can do it. 3 seconds. 4 seconds. 5 seconds. 6, 7, 8, 9, 10, 5 more. 1, 2, try again. 3, 4, 5. Are you finished? Raise your hand if you are not. Again, 5 minutes. 1, 2, hey, drop, please, if you finished, to drop your cell phone. If you finished, please drop your cell phone. Wait. Hello? Okay. Yeah. Raise your hand if you missed the roll call. And raise your hand if you had passed the code to the absent student. Raise your hand. Good. Yeah, the mode. And example 3 to 7, 3-7. Okay. Hey, in some occasions, the mode can be not unique. It can be more than one. In this case, it is not unique. Hey, the number of licensed nuclear reactor. Uh, that's an observation. That's an observation of 15 years. So the first of the 15 year, in the first of the 15 year, there are 104 licensed nuclear reactor in the United States. And the second year, 104. Third year, also 104. No, nothing get changed. All right. And then lastly, the 14th year, 111. 111 licensed nuclear reactor. And finally, the fifth year, there were 109 licensed reactor in the United States. Okay. And what are the values that occurred or occurs most often? Hey, we see in this example there, 104 occur 5 times, and also 109 occurs 5 times as well. Understand? So what are the what is the or what are the mode in this case? The mode can be 104 or 109. So both can be mode. So in this case, 104 and 109 occur 5 times. So they are both modes. I forgot. ACE. You're a mode, and so am I. 104, 109. So the number of mode can be more than one. In a data set. Can be more than one. Okay, not necessarily unique, but in some occasions, the number of mode can be 0, no mode. Hey, note that, for example, the data in example 3 to 5 has no mode. So if you wanted to calculate, if I find the mode in a data set, hey, be aware that the number of mode can be 0, or can be 1, or can be more than 1. Okay? In this case, there is no mode. Example 3 to 5. Which example? Yeah. In this example, 3.8, no, 3. Not this one. Eh? Where is the example 3 to 5? No, 3 to 5? Wait. Example 3 to 5. Let me take a look. In example 3 to 5. Please go to page 1 to 3. Tornadoes in the United States. In this example, the number of mode is 0. No mode. The mode does not exist. Hey, put my word in your textbook. The number of mode is 0. There is no mode in this data set. A 10-minute break. Number one, the number of a mode in a data set can be one or more than one, or there might be no mode in a data set. Three possibility. Okay, three possibility. Now, there are other alternative measures of a central location, but I'm not going to introduce them all because we are a little bit behind the schedule. Okay, we don't have time. Our time is so limited. And I think I have already introduced three measures of a central location, and that's enough. And I'm going to introduce another idea here. I have to wipe them off. I don't want to have my salary cut. Hey, don't report to the administration that I use Chinese here. And you don't have evidence because I have wiped them off. Now, let us look at there are two data sets here. Hey, there are two data sets here. The first data set is in the upper part. Hey, silence. The first data set, 7, 8, 8, 9. In this example, mean equals 8, median is also 8, mode is also 8. And so is the second data set. Mean equals 8. Median is also 8. Okay, the average of 8 and 8 is still 8. Understand? And mode is also 8. Hey, so what are the difference between? What is the difference between the data set? Two data set. What is the difference? The main difference. Hey, raise your hand if you wanted to have extra bonus. Raise your hand for extra bonus, volunteer. What is the difference between the two data sets? They have the same mean, median, and mode. But what is the difference between the two data sets? Raise your hand if you know the answer. Yep. What? That's not my point. But is the difference right? But it is not my point. What? Health point. Yeah. Yeah. Yeah, you get the point. The upper part, hey, data in the upper part is more clustered, understand? And the data in the lower part is more dispersed, widespread, understand? So what is the difference? Hey, you tell me what is the difference between the two data sets? Yep, good. Hey, you have extra bonus. Please give me your name or student number. I have to go back to the iClass. Score here. Extra bonus. Okay. Yeah. Can I have your name? No, Liu Guan, I remember. I remember your name. Where is it? Please tell me your position, upper, lower, or middle. No, let me browse. Hey, hey, you two ladies. If you see your name, please stop me. Hey, later. If you see your name, please stop me. Wrong class? Oh. This one? Yeah, extra bonus. Liu Guanliang. Hey, stop me if you see your name. Yeah, here. Yeah, 0.5. And you? What? Lower? Lower? Where is it? Huh? Number 12? Seat number 12? Your name in Chinese, please. Your name in Chinese. Jia Yu. Oh, yeah, 1. And the other one? 6, 1, 6. 6, 0. 16. Yeah, what's name in Chinese? Okay, also 1. But you got 0.8 because you are the last. You know the answer first. Okay? Are you satisfied? Don't complain. Okay. Yep. Um. Hey. This example is very simple. So simple that we can easily tell the difference just by looking at these numbers. Yep. You don't understand? The top one is the data are close to each other. It's so clustered. Yep, clustered. The lower part more widespread. Yeah, more dispersed. Understand? Separate. So separate. So separated. Okay. Two data sets have the same central position because their mean, median, and mode are all the same, but they are so different. Why? But they are very different. Why? Because the second data set is noticeably more dispersed than the first. Okay, and in this example, two data sets are easily to tell the difference. Okay, we can tell the difference by just looking at them. But what if data? What if data are more complicated? Like there are 100 or 1,000 or 10,000 number of observation, right? So is there a device? Is there a formula to measure how widespread they are? How widespread? How dispersed Is there an indicator? Yes, we need an indicator, not just by looking at the numbers. So the first measure of a variation, okay, or the first measure of dispersion is range, R-A-N-G-E, okay? The range is defined as the difference between the maximum and minimum value of a data set, okay? For example, the upper part, the first data set in the previous example, the maximum value is 9 and the minimum value is 7. So the range is 2 for the data set, first data set. And in the second data set, the maximum value is 15, 1, 5, and the minimum value is 1. So the range is 14, 1, 4. Okay, so which one has bigger range? Which one has a bigger range? Which one? Bigger range. And we saw in the last example, which data set is more dispersed? The second also. So in general, hey, in general, bigger range in general implies larger dispersion. Understand? And a smaller range in general, don't forget the two words, implies smaller dispersion. Okay? Sorry, please give me time to save my money, my salary. Please give me some time. Okay. In general. So the idea of range is very simple. So what their range like mean. The mean we just saw in the previous hour. What happened to what is the shortcoming or the drawback of mean? What is the drawback of mean? Hey, if you want extra bonus, raise your hand. Okay. What happened to mean? What's wrong with mean? It's easily influenced by the extreme values. Okay. And what happened to the range? It has the same problem as the mean. It is also easily influenced by the extreme value. Okay. So we need another measure to fix the problem. Okay. Note that the range also tends to be influenced by the extreme values. Okay, please give me some time to save my money. Note that the range also tends to be influenced by the extreme value like mean. And we will revisit the idea of range when appropriate, when time permits. We will revisit the idea of range in later weeks. Okay, like the case of mean, like mean. Okay, we will revisit the idea of range in later section. In a later section. Okay, and let us first go to another measure of variance, of variation. Now there are two other measures of dispersion, variance and standard deviation. So to calculate the variance and standard deviation, we have to first obtain the mean value, mean location. Hey, we sum them up and then divide it by the number of observation. In this case, the number of observation is 6. So we sum them up and divide it by 6. Okay? So the average number or the mean value or the central location is 35. Okay? If you remind me to wipe them off, I will also give you extra bonus if you remind me to save my money. I will also give you extra bonus. Okay. In this example, what is the central location of this data set? Hey, here the number is of X bar is 35. 35 and 35 is not one of the 6 it is not any one of the 6 numbers. Okay, it is the central location we obtain from the 6 numbers. Understand? If like this one, the 60, okay, is so far away from the central location. All right? So we calculate the difference of each observation, the distance of each observation to the central location. For example, x5 is 50, and we calculate the difference between the distance between x bar and x5. Okay, so the distance is x5 minus x bar. So that's the difference between the two numbers, the 51 and the central location. And we also calculate the distance between 60 and 35. And also the distance between 10 and 35. Hey, just calculate all the 6 differences. If you are far away from the central location, there, if every observation is so far away from the central location, then the data will be more dispersed. If they are so close to the central location, then the data will be more clustered. Okay, so we need to calculate the distance between every observation and the central location. So let us calculate them all and sum them up. Back to the previous example. Hey, 7, 8, 8, 9, and the second data set, 1, 8, 8, 15, so that we can make a comparison. So we have two data sets. We have two data sets. Here, We have two data sets. The first data set is what? Yeah, here. Yeah, here. You see this? We separate them by the red line. The first data set is 7889, and we calculate the difference of between every observation and the central location. 8, 8, 8, 8. Here 8 is the value of x bar, and we sum them up. And before we sum them up, we have to square them. 平方, we have to raise them to the power 2. Why? Why? Tell me why. I ask you very often because you are sitting closest to me. Otherwise, it will be, if you don't square them, the sum will be trivially 0. Okay, positive and negative, they cancel each other. Trivially 0 if you don't square them. Okay, so if you square them and divide it by 4 minus 1, okay, then the result is 2 over 3. And second data set, the distance between the first one and the central location, second one, third one, and central location. The fourth one, the distance between the fourth one and the central location. Hey, don't forget to square them up. Otherwise, the sum will be trivially 0. The positive ones and the negative ones, they cancel each other, and the result will be trivially 0. Trivially 0 means they are born to be 0. Don't forget. To square the distance over the sum will be trivially 0. Okay? Is it TRIVIALLY? Is it? Did I spell it right? Yeah, trivially. Trivial. Yeah. What? Later. Yeah. Yeah, trivially. Yeah. Oh, yeah. I will tell you the difference. Hey, in your textbook, the symbol is a sigma, but in my formula, the symbol is S, capital S. There are different. It's different. My definition and your textbook definition are different. I will tell you the difference, okay? Hey, don't forget to square the distance. Hey, don't I forget the ace. Hey, don't forget to square the differences. Yeah, you are asking good question. I will give you extra bonus later. Don't forget to remind me. Differences or the sum will be trivially zero. All right? Hey, so divided by the number of minus 1. Hey, divided by minus 1, minus 1. Okay? So uh the value of capital S square is called sample variance. Sample variance? Okay, variance. Hey, which one has the bigger variance? Which one has the bigger variance? Which one? Which one has the bigger variance? The second data set. And hey, bigger variance like a range. That like the case of a range. Hey, bigger variance implies bigger. Raise your hand if you know the answer. Bigger variance implies bigger what? Bigger variance implies bigger what? Bigger dispersion. Okay? And don't forget, in general, bigger variance implies bigger dispersion. Okay? What happened? Yeah, here. Hmm? Hey, what happened? I forgot to insert. Hey. I forgot to insert. I missed some slides. Hey. Please give me some time to fix the problem. Here, this one. Yep, here. Yep, this one. And this one. And this one. No more. Okay. Yep. here. Hey, in general, if bigger variance implies bigger dispersion, a larger dispersion of a data set. Okay? If this is bigger, or this is big, if or this or this, if they are bigger, then the data set is more dispersed. Okay? Don't forget. To square the distance. Or S square will be trivially 0. Or the sum okay? Used rarely. We hardly use it. And used most often. Very often. And I know why. I know the reason why, but I cannot explain it to you because you have limited knowledge to understand my explanation. Very often. Why? Because it is very useful, very helpful. Okay? And the code the sample variance. Hey, sample variance. Sample variance. Hey, you see the word sample? You must think of its counterpart. Hey, when I say sample, you must think of in your brain that there must be a counterpart called population variance. If you see sample variance, then there must be population variance, which is the counterpart of sample variance. And I'm answering you a question. Hey, I am answering your nice question, and I say I will give you a extra bonus because you raise a very good question. What is your name? 331 is seat number. But seat number, not student number, seat number in this class. Or just your Chinese name. 你好做什么名啦？ 啊，6 OK，蔡善林0.8 I mean semester score 学期总分 OK extra bonus hey you will see later that we will use this instead of this. We don't use this because it is so hard to derive. It's a statistical property. The right one, the one in the right, is better. It has good statistical property, easy to derive. Okay, and then we call the sample variance. And in general, bigger variance implies larger dispersion of a data set, like the idea of range. Okay. Okay. Now let me tell the difference between sample variance and its counterpart, population variance. They look the same, but they have a different meaning. Yeah. Sample variance and population variance. Okay. And sample variance is xi minus x bar square I from 1 to little n divided by little n minus 1 of dispersion to measure the dispersion of a sample. X1, X2, all the way to Xn are from values in a sample. Okay, but if you calculate xi minus x bar square I from 1 to capital N, it is to measure the dispersion of the whole population. Whole population mean more and more numbers, much more numbers than sample. The whole population. X1, X2, Xn are values in the whole populations of the whole population. Or if true mean is known. If mu equal, and hey, this is the mean average value of the whole population is known. Hey, if the value of the true mean means mu. Hey, reads this symbol reads it is Greek letter. This is called mu, mu. Okay, a Greek letter. Hey, what is mu? Mu is the average value of the whole population. Hey, from x1, x2, all the way to x sub capital N. Okay, the whole population, like all TKU girl students' heights. That's the population. And for example, this one, x1, x2, all the way to x100. 100 sample is a sample. A sample is a subset of the whole population. Compared to population, sample, the sample is a smaller set, much smaller set, and a subset, always a subset of a population. Understand? Hey, you know the difference? You know the difference? What are you tell me the difference? Is based on sample. S squared is not a sample. It is based on a sample. The all observation, all the values in the whole population. Understand? Yep. The middle one, the bottom one. This is the fake mean. Fake. F-A-K-E, fake mean. This is the true mean. Okay? Often, it is often unknown. In this case, we use the fake one. Understand? And what is the true one? The true one is the sum. Oh, no, not squared. It should not be squared. Hey, it is a typo. Hey, this one is defined as the grand average of the x1, x2, all the way to s capital N. Hey, this is the all the numbers in a population. Understand? You know what I mean? Which one is the fake one? The upper one. And which one is the true one? The lower one. Yep. And can I square xi? No. No. We cannot square xi. It is a big mistake. Big mistake. Hey, no square. So that's the difference. So x squared is a counterpart, counterpart of s squared, and vice versa. 反之亦然呐。S squared is a counterpart of sigma. Hey, I should not use a, I should use the. Okay, counterpart. When I say counterpart, means they are, you know, they have the same idea, but you know, counterpart means, I don't know how to explain in English. Just, you know, 对等单位了，对等的东西了。哦， they have similar idea, equivalent. They have equivalent importance, means counterpart. Okay. And a sample standard deviation. Hey, another measure of dispersion is the sample variance. Please give me time. Sample standard deviation, ACE. Okay. They are trivially the same. But the right one, hey, don't panic. 卖點扯講啊. But the right one is more convenient to use. To use. Convenient. Am I spelling right? Convenient. Oh, E, not I. Easier to use. They are trivially the same. Not sample. The same. S-A-M-E. Trivially the same means they are born to be the same. So the equality sign is different. Hey, I use 1 line, 2 line, 3 lines to denote they are the same. Okay? And we will be back for this next week. Don't panic. Roll call time. Unless you don't want extra bonus for your attendance. You don't want it? All right. Again, 10 seconds. Because I don't want you to pass the code to the absent student. One second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10. All right, please come to me if you miss the roll call. Yep. Hey. Hey. 那就没有加分而已啊，我又没扣分，我没扣分啊。不会，也不会扣考什么的。 工价也一样，我都没有在调那个的，因为你就是我就是来有加分啊，那你要把你身体顾好啊，好不好？哦，sure, sure. Yeah, you create an account, exclusively for this. Yeah, 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 yeah. Good, good. Yeah, and yeah, sure. And you please tell me the ID and a password to log into the YouTube. Okay. Okay. Yeah. Okay. 嗯，你是那个统计 EB 的，嗯，
因为已经糊掉了，我又去印。
你是哪一国学生？你是哪里来的学生？你怎么讲中文也怪怪的？你怎么了？哦哦哦哦哦哦，嗯，什么名字？陈丽如。你坐在前面后面还是中间？哦，找到了。好，算你有出席哦。还有一次，2次点名。好，那就先这样哦哈。好好。Yep. Yep.
Why this one you write it? The N is not capitalized and this one is the capitalized.
Capital M is bigger because population is always much bigger than a sample. All right.
What is the difference like in
What?
this one? This the comparison.
This one and this one?
Yeah.
Just the number of observation. One bigger, one much smaller. But they are close. If n is big, little n is big enough. Can you understand my English? You are a local student or you are from Vietnam, Indonesia? Oh,
Quite simple words. That
oh, really?
yeah. Not that hard vocabulary. Don't learn
What?
hard vocabulary.
Hard vocabulary. Why? Me?
Yeah, not
Oh, no, not that hard. Oh. Okay. Thank you. The 9th or the 10th week. Yep. Yep. Okay. Bye-bye.